10.2 and 10.3. Of course, the first couple of pings might fail because the ARP process is taking place, but those pings should be successful. Of course, you want to verify that you can actually ping the device before you try to SSH to it, because if you can't ping it, most likely you're not going to be able to SSH to that device either. I'm going to ping 192.168.10.3 as well to make sure that I can ping the other switch as well. Now, we didn't set up SSH on the right switch, so we're not going to try to SSH to that device, but we are going to try to SSH to the left switch. Let me know if your pings are successful. Yes, no? You good to go? Okay. So go to the switch on the left. And let me see your configuration. Enable. Did you do all the configs on the right switch?
Yeah, that was the one that I deleted.
Okay, let's do a show run on the right switch now. Space bar. Okay. Well, then just ping 10.3.
I didn't. I don't know why I didn't. I did 10.3.
It worked.
Oh, actually I didn't.
Well, because of ARP, right? I mentioned that. The first ping will fail because it's doing the address resolution.
Right, you're right. I saw 1 and 2 fail. And then I saw 3, the first one failed. I just assumed that it was. Okay.
Okay? How about yours, sir?
Good.
Okay, now that you can ping it, we can go ahead and SSH to it. We use the command SSH-L for login. We put in our username, which in our case is Cisco, hopefully. And then we put in the destination IP address, 10.2 in my case, not 10.3, 10.3 in your case, and 10.2 in your case. And notice my banner popped up, system warning, protected system monitored. The system is being monitored. But I have now established a secure shell connection to my switch. So this is an encrypted session. No, -L and then the username. L is for login, so you're going to specify the username and then the IP address. Of course, you could use Putty as well, but Packet Tracer doesn't have Putty integrated. And then your password. Now you have a SSH session to your switch. Okay? No, SSH-L, the username, then the IP address. Should be Cisco, right? No? Cisco. Well, it's not your secret password. It's whatever password you assign to a user.
Right.
Okay?
Why didn't it ask for the username if we had login local?
Because you
I
put the
already did.
username in the command to SSH.
Yep.
Right? All right. Now, had you used something like Putty or something, it would have asked you for a username and then a password, but we put the username in the command to SSH. So now we've established a secure shell session to our platform. So it's actually fairly simple to configure SSH. Windows doesn't support SSH unless you have PowerShell configured, but this is Packet Tracer. It's not Windows. It is a simulator, and they've added the SSH option into Packet Tracer. All right? Okay? Windows does support SSH if you install PowerShell, which you can download for free. But we would normally just use Putty or some sort of terminal application to connect via SSH on our Windows platform.
SSH configuration, if you forget one of these steps, does it just let you continue on, or will it actually?
What do you mean if
prompt
you forget what step? Which
Like,
step
let's
would
say
you?
you forgot login local.
Then it wouldn't work.
So, I mean, but would it prompt you while
No.
you're setting it up? It just let you continue on and you wouldn't find out until you try?
Yeah, it's like saying, okay, I want to go ahead and turn on an interface and give it an IP address. But I go into the interface and I turn it on, I don't give it an IP address. The router's not going to say, well, you turned on your interface, but you didn't give it an address, so it's not going to work. Obviously, it's not going to do that, right? You have to know that that's part of the configuration. You have to apply that configuration. Make sense?
Yep. We're just looking at this because this is one of the things that they want our level of techs to start doing instead of passing it to the network group.
Sure. Yeah, and it's important. You guys need to understand that, these devices are going to do whatever you tell them to do. Now, there are certain things that will give you errors. For example, if I generated my crypto key and I just hit enter for the modulus of 512, when I go to enter IPSSH version 2, it would give me an error because I need at least a modulus of 768 in order to run SSH version 2. Okay? So some things will give you an indication that you may have done something incorrectly, but some things will not. Here's the command that we use to connect to our platform. In our particular case, we just had a user called Cisco. In this case, we had a user called Cisco user. By the way, this is the command that we use in a router or switch to SSH from one device to another. That's actually the Cisco syntax. SSH-L, the user, and then the destination IP. This would not be something we'd use in Windows, because in Windows we would just simply say SSH, enter, and then it would ask us to specify the destination address, and then we would put in our username and password. Okay? But if I'm on one Cisco device and I want to SSH to another Cisco device, this would be the command that I would use to do that. Okay? This also happens to be the command that they set up in Packet Tracer for our desktop.
Can I ask you a question?
Sure.
What setting or what configuration would be on the devices to where you just go SSH from one, let's say you're on a switch. Let me back up. I'm in my office, I can't get to a switch, but I can get to another switch. So I try to go from the accessible switch to the other one, and we're just putting in SSH and then the IP of that other one, and it actually, if it is accessible, it's creating that
Sure.
channel.
Yeah. You don't have to do the -L. That's a switch.
Okay.
Right? You can just SSH and then the IP address, and then it's going to ask you for the username. It's going to ask you for the password.
All right.
We're just using a switch here that allows us to specify the username in the command. All right?
All right. I see.
It's like doing a ping. You can do a -T if you want to do a persistent ping, or if you just want to do 5 pings, you just do a normal ping, All right? Of course, when you connect, usually we're going to use something like Putty. And then you'll notice this message pops up. The server's host key is not cached in the registry. You have no guarantee that the server is the computer you think it is. The reason you're getting that kind of message, and I'm sure you guys have seen this message, maybe in different formats, but this message will pop up, is because most of the time, when we're setting up a SSH on a platform for management, we're generating our own certificate. We're not getting a certificate from a third party. So what this message is telling us is that the certificate cannot be authenticated because the person who's supplying the certificate generated their own certificate. It's not necessarily a bad thing. It just means that we can't authenticate or verify the authentication of that certificate. All right? But in the case of management, our goal for the certificate is not for authentication. Our goal for the certificate is for encryption. We're using the certificate in something called a Diffie-Hellman key exchange process that allows us to establish our AES bulk encryption key. Well beyond the scope of this class, not so much beyond the scope of the security portion, which is on the weekend, but essentially this message is just saying, hey, I can't verify the authenticity of the certificate. It hasn't been signed by a third party. Are you sure you want to connect? You can say yes. Now, where do you not want to see this message? If you're going online to a bank, or if you're going online to perform some secure transaction with a shopping cart or something to that effect, you definitely don't want to see this kind of message, because that generally means that you're not able to authenticate who you're actually connecting to. Most of those people, the banks and Walmart and Target and anybody else that does any kind of financial transaction online, is going to get a signed certificate from a certificate authority, which is just a third party that verifies the authenticity of the person they're issuing the certificate to, which would be the consumer, right, or the purchaser of that certificate. Okay? A couple of other basic things that we can do on our device. We can set up speed and duplex on our interfaces. By default, all of our interfaces have a speed of auto, and duplex of auto means that they're auto negotiated. But in some cases, you might actually want to configure those physical ports with manual configurations. Very simple. You go into global configuration mode. You go into the interface that you want to modify. In this case, interface fast Ethernet 01, and you can set the speed using the speed command. You can set the duplex using the duplex command. All right?
I always get mixed up on that. Which one is it you should do first so you don't lose your connection?
Shouldn't matter. No. Either one. Yeah. Now, there is a potential of losing the connection if you accidentally set the configuration to something that won't work with the other end, right? If the other end is hard set to full and you accidentally set yours duplex to half, then you'll lose your connection and it won't come back because those ports are not compatible with each other. Now, if one side is set to auto and you set your side to half, you might lose your connection temporarily, but it might come back because it gets auto negotiated on the other side. All right. By the way, when there is a mismatch, what happens? Let's say that we're both auto, but we can't negotiate. For some reason, we can't negotiate the speed duplex. What happens? We revert to the least common denominator. So in this particular case, I would go down to 10 meg and I would go to half. All right. If auto negotiation fails, the switch or the router assumes the worst case scenario, which is a bad thing. Because what happens if we're in half duplex? What does that mean to be in half duplex?
You can only send, only one can send at a time, and they have to wait for the other to receive, and you can go get a lot of latency.
Well, you get collisions, you get latency. Half duplex means that you can send or receive, but you can't send or receive at the same time. You have to either send or receive, but not send and receive at the same time. Now, most of the time, you're not going to have to worry about this. Most of the time, auto negotiation works just fine. All right. How do I verify what the interface is configured for? I use the show interface command. And if I run the show interface command, I can see the speed of duplex. Now, it doesn't tell me whether it's configured statically as full or 100. It just tells me what it's operating at. It just tells me what it's operating at. So if you guys were to run this command right now, you should see a similar output for Fast Ethernet 01. Because you guys actually have a device connected to Fast Ethernet 01. Right? Sorry?
No, I'm just checking the show interface description after I did the show interface fast. 01.
Yeah, there's a lot of stuff you're going to see for show interface, but speed and duplex are listed there as well. You're going to see a whole bunch of things. You're going to see the MAC address of the interface. If there's an IP address assigned to it, you'll see the IP address assignment. If you'll see speed and duplex, of course, you'll see things like queuing information, buffer information, collisions and errors, CRC errors, all kinds of things. All right? Which brings us to one of the most important outputs that you guys will use in this class. Actually, I would say probably one of the most important commands that you use in general. Show IP interface brief. This is a command that I would equate to like a Phillips head in my tool chest. You know, you got your tool chest. Some tools you use some of the time, but there are certain tools that you simply cannot live without. And a screwdriver would be one of those tools that you wouldn't be able to live without. This command is like that screwdriver in your tool chest. We use this command all the time. And you guys are going to be using this command quite a bit. All right? If you run this command on your switch right now, you'll see a list of all the interfaces that you have on your device. Okay? So you'll see the interface column represents all the interfaces that you have on the device. The IP address column represents whether or not there's an IP address assigned to that interface. And of course, in our case, there wouldn't be because they're all layer 2 interfaces, with the exception of our VLAN interface that we set up. And then we see two of the last columns, the status column and the protocol column. Now look what it says in the table. The line status, okay? Line is the first column, protocol is the second column, all right? It doesn't say line status in the name of the column, but that's what it's referring to. Line status is the first status code. Protocol status is the second status code. So we have these two columns here. What does the first status code represent? Layer 1. For example, if you have a cable installed and it's the wrong cable, or the other side of the cable is not plugged in, or the device on the other side is not turned on, you will see a status of down. Down means that there's no physical layer status. The second column represents layer 2. Okay? So, just take a look, for example, at Fast Ethernet 01. I see a status of up. I see a protocol of up, which tells me what? It tells me that both layer 1 and layer 2 are working on that interface. There's a physical cable attached, and I'm getting some sort of encapsulation on that interface, which would be Ethernet in this case. What about the second interface, Fast Ethernet 02? I see a status of down, down. What does that tell me?
Either nothing connected or whatever's connected is off.
Right. Either I have the wrong cable connected, the cable that is connected is bad, or there's no cable connected at all. But down, down means I have to troubleshoot the physical layer. I have to troubleshoot the physical layer. All right, there's actually four different status messages you'll see, and we see them on this slide here. Administratively down means that the interface is actually shut down. All right? By the way, administratively down would be the line status. Then the protocol status would be down. And obviously, if the interface is shut down, I'm not going to get any layer 2 status, right? Makes sense. So the only time you ever see administratively down is if the interface is actually shut down. Down, we already talked about. That means that there's an issue with layer 1. However, the interface has been enabled. Because I don't see administratively down, I just see down. All right? So if I see a status of down, I'm going to troubleshoot layer 1. There's absolutely no reason to start troubleshooting layer 3 or layer 4, application layer, or layer 2. Until I can get layer 1 working, nothing else is going to work. What about up-down? Up-down means that the physical layer appears to be working. I've got a cable attached. I'm getting a heartbeat over the wire. But something is wrong with the data link layer. Could be a encapsulation mismatch. If it's a router, maybe I'm running HDLC on one side, and on the other side I'm running PPP. Typically, we don't see encapsulation issues on Ethernet because Ethernet is pretty much assumed to be Ethernet 2. Could be a clocking issue if it's a serial link as well. We'll talk about clocking a little bit later on. Now, as far as up goes, that means that the physical layer and the data link layer are working. That doesn't mean that the interface is configured correctly. If it's a router interface, for example, I can see up even though the router interface might not have an IP address assigned. Because what does the up refer to? Layer 1 and layer 2. But an IP address is layer 3. Follow what I'm saying? So just because you see up doesn't mean that everything should be working on that interface. It simply means that the physical layer and the data link layer are working. All right? It simply means that the physical layer and the data link layer are working. All right. Now, as far as testing connectivity goes, we've got ping that allows us to check our connectivity. You guys already did this ping. We know what ping is. It's an ICMP message. Also notice in this case that the first ping failed. When you see that, that generally means that we're trying to establish a connection to this device for the first time. So we're going through the ARP process, address resolution protocol process, where we're ARPing the MAC address and trying to discover the MAC address. Okay? You guys following so far?
Yep.
Trust me, this is all the basic stuff. We're going to be getting into much, much more advanced stuff throughout the rest of today and into tomorrow and so on. The switch boot sequence. When a switch boots up, the first thing it does is we check something called the configuration register. Now, normally you would not change the configuration register. You would only modify the configuration register, which is like kind of like adjusting BIOS settings, if you're trying to troubleshoot the device. So let's go ahead and assume that the configuration register would not be modified. Okay. So we're going to kind of progress to the next step, which is check for boot commands. All right, and load the appropriate iOS images. Now, we know where iOS is stored, right? Where is iOS stored? You guys should know where iOS is stored. It's stored in Flash, right? It is possible to have more than one iOS image on your device. However, you can only load one. So one of the options that you have is to tell the device which iOS to load. That's what they're referring to there when they're talking about a boot command. There's a command that you can enter called boot system that allows you to identify which iOS to use. What if I don't have a boot system command specified, but I have multiple iOS images in Flash? Which iOS image is actually going to get loaded? Any ideas? I have 3 or 4 iOS images in Flash, which by the way you never really would, but let's just say I do. 3 or 4 iOS images in Flash, which image is going to get loaded if I don't tell the device which image to use?
That, the startup config?
We're not even at the startup config yet. We're talking about loading the operating system. We haven't even gotten to loading the configuration yet. Okay? Says right here, if I have multiple Cisco iOS images in Flash, I'm going to load the first image listed in the directory. So it actually loads them based on how they're ordered in the Flash itself. If you do a dir Flash, whichever one comes first is the one that gets loaded. Okay? Now, again, I have to say it's not common to have multiple images on a platform. Usually you're only going to have one image. But sometimes you'll have multiple if you're doing an upgrade and you're kind of halfway through that upgrade process. So just keep in mind, if you do have multiple images in Flash, it's just going to load the first one it sees in the list, which is usually by alphabetical order. Okay? Now, if there is no iOS image in Flash, for some reason or another, somebody deleted their Flash or accidentally erased the iOS image, then what the device will try to do is load an iOS image from a TFTP server, if that option has been configured. Because, of course, in order to load from a TFTP server, we'd have to specify all of the TFTP server parameters. That is not done by default. So if you haven't configured TFTP as a boot option, then at this point, we're going to completely fail, and we're going to go into something called ROMMON mode. ROMMON is a prompt that essentially allows you to recover the device, but the device is not functioning. You do not want to see your device in ROMMON mode. ROM stands for read-only memory, and in ROM, there's a limited version of iOS. It basically keeps the device from being a brick if it can't load an image. Right? Windows machines don't have that, right? If you're booting up your computer and you can't find an operating system, it just gives you a message on the screen that says no operating system found, right? And you can't really do anything with that. In the Cisco world, they decided to at least give you some sort of limited iOS so that if for some reason the device doesn't boot, you can go into this ROMMON mode and you can try and recover the system, right? A copy a file to the system or whatever you have to do. Okay? So the first step in the boot up process is to load the iOS. The second step is then to load the configuration. Now, as far as the switch goes or router goes, we automatically boot by using the boot variable. Now, these boot variables are not set by default, right? Remember I said there was this boot system command? I just gave you an example of what that boot system command is at the bottom of this slide. It's a global configuration command where you can specify which image to load for the device, all right? If this boot variable is not set, the switch performs a top to bottom search through the Flash file system, and it executes the very first bin file that it finds, which might not be the latest version. It just depends on the file name. It totally depends on the file name. Now, if there's only one iOS image in Flash, no problem. It's just going to load that image.
Is it best practice to name the server?
No. In fact, I've never done it. Never done it. The only reason that somebody might do something like that is if they upgrade their images on a regular basis, and they don't want to have to touch every router to do it. They would just upgrade the image in flat and TFTP. But here's the problem with using a TFTP server as your boot source. What happens if the network's not working? What happens if the TFTP server fails? Then all of a sudden your devices can't boot up.
Oh, so that's not a backup, that's the primary?
What do you
That
mean?
would be, you said if it doesn't find.
You can use it as a backup.
Okay.
You can use it as a backup,
That's
yes.
what I thought it was.
It can be used as primary also, right? Now, as far as using it as a backup, is that best practice? I would say no, that's probably not best practice either. Although, I guess there's nothing wrong with that. You could do that, I suppose. There are several configurations you have to apply to the device to be able to do that, right? So it does add a little bit of complexity to your initial configuration. But yeah, you can use the TFTP server option as your primary as well. It doesn't have to be a backup. All right, now the device is booted up. It's loaded its iOS. Of course, now what does it have to do? It has to go out and get its configuration. So it's going to go through this process. It's going to say, okay, do I have a configuration file in NVRAM, which is my startup config? If I do, then I'm going to load that startup config. If I don't, then I might try to load a configuration from TFTP. Again, this is something you would have to configure in order for it to work. There is no default TFTP configuration. We don't use broadcast messages to identify our TFTP server. It's something you would have to configure in order to make that work. What happens if I don't have a startup config? I don't have TFTP. We go into this thing called the initial configuration dialog, where it's basically like the default configuration. Okay? Very simple. We don't care about the slide. I keep meaning to take this slide out. It's not really that relevant. All right. Now we know that we use the copy command to manage our file system. We use the copy command to manage our file system. The copy command has a specific syntax, source to destination. So I've given you 6 different examples here of how the copy command can be used. We'll talk about the TFTP component in a second, but I've given you 6 different options of how the copy command can be used. All right? These are pretty much the primary ones that you would actually use. Let's talk about TFTP though before we get into those 6 options. TFTP stands for the Trivial File Transfer Protocol. It is a UDP-based application that allows us to manage our file system. All right? To manage our file system on our platform. It is not a Cisco proprietary protocol. It's an open standard protocol. It just happens to be a trivial version of the file transfer protocol. Trivial meaning that it doesn't require authentication and it runs over UDP. All right? Here's the key to the exam. When you see the word TFTP, simply think of backup and vice versa. If you see the word backup, think of TFTP. TFTP is just an application that you run on your laptop or a server that allows you to copy files to and from a system. The TFTP application that I prefer to use is something called TFTP D32 or TFTP D64. One is obviously for a 32-bit operating system. The other one is for a 64-bit operating system. This is what the application looks like. This is the window. It's a very, very simple application to use. You've got a directory that you specify where the files go. You've got an IP address of the interface that's running the service. And that's it. Very simple application to use. If you go out to Google and you search for TFTPD, you'll see a website where you can download this software. It's free. It's very easy to use. It's a self-contained executable. It can be installed as a service as well, but we can also launch it as a self-contained executable. All right, simple enough. Okay, in fact, I'll show you that software here. TFTP D, and this is that interface. If it'll load. TFTP. It's already running. Okay, hold on 1 second. Didn't pop up. Oh, there it is. Of course, it's not working right now. I'll have to show you guys later. All right, but it's a very simple application. Okay? So let's go through each of these 6 options here. Yeah.
Before we start that, are we going to take a break?
We will at 10:30.
Drink in some coffee.
Oh, it's already past 10:30. Yeah, let's go ahead and take our break now. 15 minutes. I was going to take a break at 10:30, but